Hello and welcome to Boys, a cloud-native YouTube channel. In today's video, I'll be showing you how to optimize your Docker images. My name is Dr. Damien Igbe and I'm a Kubestronaut, meaning that I have passed all the 5 Kubernetes certifications, including CKA, CKAD, CKS, KCNA, and KCSA. Also, I've been using Kubernetes for the past 12 years or thereabout. For the agenda, I'm going to explain why we need to optimize our images. Then I'll talk to you about some of the optimization techniques. Again, for the lab environment, if you want to follow along, make sure you have a laptop and you install Docker for desktop, or in your laptop, you can install Minikube. In my own case, I'm going to use Docker desktop for these exercises. All right, so let's start. Why optimize your images? Earlier in one of the videos, I told you that the first thing you need to do when you have your application and you want to containerize it is to make sure you create your image. Once you create your image though, your job is not done yet. In fact, the most important thing after you create your image is to make sure that your images are optimized for security, for image sizes, and also to make sure that you improve the build time and the efficiency of your images. So in reducing the image size, you already understood that you have a Docker registry and your images are going to be uploaded to Docker registry. Also, anytime you want to run your container, you have to download the image from the Docker registry, which means that there's a time involved in when you're uploading the image online and when you're downloading the image to your work environment. So you can easily understand that if the image size is 1 GB, for example, it's going to take a lot longer to download the image than if the image were just about 10 MB. So from that perspective, it's always good to make sure that your image sizes are as small as possible. Another thing is that if your image sizes are small, your build time is going to be much less. When you're trying to build your image, if the size is 1 GB, it's going to take much longer to build the image than if it were just, again, 10 MB. Another very important point, though, is that when you reduce the size of your image, technically, you are reducing what we call the operating system footprint. In other words, if you have a large image, most likely you have a lot of applications installed on it. Each one of those applications, which you may not be using, or you may even be using, could be a potential security threat. And so the idea is that if I need just 5 applications, make sure you have only just those 5 applications in your image. Any extra one which is not really needed is not going to be a good idea to let that be in your image. And you need to understand as well that in a container, ideally, you want to run only one application. So you want to make sure that your image has, again, the code or the application and all the things it requires. Nothing more, nothing less. So the smaller the size of the image, the better it is for security. Then also, if your image is small, it's going to be more efficient. When you try to run it, the applications will have more resources dedicated to it, on and on. Okay, so these are some of the reasons why you want to make sure you optimize your images. It is not an option. In a production environment, you want to make sure that your images are optimized. And I'll show you some of the ways you can do this. So in trying to optimize your images, one of the key things you could do is to leverage the best base image. And in subsequent slides, I'll explain to you more about different types of base images. And in fact, that is what we're going to focus on in this video. Maybe in the rest of the videos, we'll talk about the other techniques here. For example, anytime you install applications in your image, you want to make sure you remove some caches which may be left behind by the installation package. If you install anything with apt, for example, in Ubuntu, it might have a folder where it uses for caching some information, but you may not need those information once the build has been done. So one way to reduce the size of your images is to make sure you remove those caches. Another way though is that you can actually have a file called .dockerignore, and inside that file you can put in a lot of information that you don't want Docker to copy to your final image. So it could be that after the installation has been done, there are certain things you don't want them to be copied over. You just put those information in Dockerignore. Another powerful technique is to reduce your image layers. When you create your Docker file, some of the commands like run gives you a new image layer. Now, the more image layers you have, the bigger the size of your image might be, because every layer has its own size. So a cool trick here is to make sure that if you have a bunch of commands to run, you can combine them into one command, and that will give you just one layer. Again, I'll talk more about those in some other videos. Of all the options I've mentioned, multi-stage build is also one of the most effective techniques you can use to reduce the size of your images. This simply means that instead of having just one from command in your Docker file, that you remember that from uses the base image. So instead of having just one base image, you can have multiple base images. The way it works is that the earlier base images are used more like installing applications, and then the later ones are just used more for the final image. So it could be that step one in the from, you have a base image, you did some installation of your applications, and then you copy just only what you want from that stage onto the next stage. And so by doing that, you left behind all the caches and all the other information that you don't want. Okay, so this can be very effective, but it's better seen than explained. Okay, so these are several ways you can use to improve the size of your images. By all means, you can combine them and use all of them. This is more of an art as well. The more you do this, the better you're going to get at it. But for now, I'll just give you some concepts which will help you in trying to optimize your images. Okay, so this video, I'm going to talk just only about optimizing your base images. Well, let's understand base images. Again, so if you look at this command here, this is your base image. Anytime you see from in a Docker file, anytime you see from, what follows is the base image. That command is compulsory. Every Docker file must have the base image, and every other thing you're doing will be built inside the base image. So as you can tell, the bigger the base image, the bigger the size of your image is going to be overall when you're done. So it's advisable to use base images that are very, very small. So different types of base images, some of them are more like traditional operating systems like Ubuntu, CentOS, Red Hat. In the early days of containerization, people were using this type of images. But today, you don't want to use those type of images because, again, their sizes are really often very large. Okay. Another type of base image are language specific. For example, if you're using Node.js, the Node.js community has created some base images and they named them Node to make them easy for you to access. And if you go to Docker Hub and you go to Node images, you can see a bunch of customized images specific to Node application. And so you can use them. Another one here, the last one here, cloud optimized images. This example of this is Alpine. You hear a lot about Alpine, BusyBox, or even something called Scratch. These images have been customized for, I can say, the cloud or the containerized environment. So if you compare an Alpine image to Ubuntu, for example, Ubuntu may be, let's say, maybe 300 megabyte, 200 megabyte. Alpine may just be about 10 megabyte or less, or slightly more than that. So there's a huge difference in the size of these images. And as much as possible, we want to use these cloud optimized images like Alpine in the sense that this has everything removed and only what you need is included in it. For most applications, they'll be sufficient. Some applications, they might not, but better you try and see if Alpine is not sufficient for you, then by all means, maybe use some other images. Again, within the language-specific optimized images like Node.js, you're going to have some versions done with Alpine as well. So I'm going to show you a couple of examples, and I might use just two applications, Educate and Node.js application. Again, I've been using Educate in all the previous demos to show you how you can reduce the size of the images based on the base image that we're using. So I have different scenarios here. All I'm going to do is, this one here is using Ubuntu base image. This one here is using Nginx. This one here is using Nginx customized with Alpine. This one here is using Apache Web Server. This one here is using Apache Web Server, again customized with Alpine. So the idea is for each one of these scenarios, I'm going to build the image and then I'm going to show you the size of the image. Once I'm done with that, we'll compare the images and you see which of these gives us the most efficient image. In other words, which of them gives us the smallest image. After that, I'll also come here and show you another example with Node.js with a very simple application. And at the same time, we're going to go through using different images, traditional base image, from Node customized image, then Node Alpine, which is done on an Alpine image. And then you see this one here called Slim. Slim is pretty much going to be very similar to Alpine, but we'll compare the both of them and see which of them is actually gives us the smallest base image. Okay, so this will be exciting. Let's go ahead and build the images. So basically, I'm going to copy these lines here and then show you the images. Okay, let's copy this. Then come here to my environment. Okay, so in this folder here is my Educate application, and I have a Dockerfile here. But this Dockerfile, I'm going to be erasing the content and then building the image to show you. So let me erase the Dockerfile. I'm just going to say echo, just to make sure that the file is empty. So I'll open it, Dockerfile, and I'll paste this information here. Okay, so I'm always using Vim for my demos, but feel free to use any other editor that you are comfortable with. Okay, so this one here is using the base image of Ubuntu 22.04. What that means is that I need to do more work. I need to update the server, then install Apache myself, then copy my Educate application to that directory, and then make it available, and then make sure that I start Apache. That's all I'm doing here. So I save it, and I do docker build -t. I'm going to call it educate 1. I'll just call them 1, 2, on and on like that. Okay, so educate 1 and then put dot. Okay, so this has built. If you are doing this from scratch, it will most likely take longer than this, but because I've done it before, it's much quicker. Okay, so let's do docker images, and let's go grab educate 1. Okay, educate 1. Okay, so this is the one we just built, which is educate, and the size is 232 megabyte. Okay, so let's open the file again. Okay, so quickly I'm just going to remove all the lines, go back to the slide, and go to the second one here, then copy this one here, which is coming from the Nginx web server as the base image. Okay, now we do that, and then we build this image again. I'm going to call it 2. Okay, so let's see. Because I've done them before, they might be a lot faster. Okay, so this one here is 200 megabytes. Remember the one before was 232 megabytes. This is 200. So we have been able to reduce from 232 to 200 with a saving of 32 megabytes. Let's see how far we can go. So I'm going to open the Docker file again, and I'm going to delete. I'm going to go back to this one here, and I'm going to use Nginx, which was configured on Alpine. Okay, so let's use that one, see what size we're going to get. I put that there, save it, build it. I'm going to put 3 in this sense, in this time. Okay, so let's see what size we got. Okay, this is version 3, and let's make sure that we can see everything in one line. Okay, so this one here was number 3. That is the one we just built. Number 3 here, which is the third one here, is 21.5 megabyte. 21.5 megabyte. See, from 200 to 21, or from 232 to 21. So with this one here, we're saving roughly 200 megabytes, more than 200 megabytes. With this one here, we're saving roughly 180 megabytes. So let's see what we can do more. So come to this one here, and then we're going to use Apache. The one we did before was Nginx. Now we're trying to use another web server, which is Apache. So again, open the Docker file, erase what is there, paste this one here, and then build it again. Let's make this one 4. Okay, let's see that 4, size of 4 is 180. Okay, so we're using this Nginx web server similar to the first one we're using Apache web server similar to Nginx, and we see that the difference between them is just 20 megabytes. So overall, we can see that maybe in this case Apache seems doing better in terms of size. But overall, this is the best one we had so far, which is using the slim version of Nginx. So let's say the final scenario is going to be this one here, again using the Alpine version of Apache. So now we're comparing the Alpine version of Apache versus the Alpine version of Nginx. So we open again Dockerfile, remove what is here, paste, and then we save, and we build it. Let's make it 5. Okay, build again. Okay, 5 is of a size 75. 5 is of a size 75 megabytes. Okay, so overall, these are the images we just created. 1, 2, 3, 4, 5. And the smallest of them is 21.5 megabytes. That one is coming from Nginx Alpine, which is this one. So this is our winner. So I would say that if I want to build this application, I'm better off using this basic image of Nginx with Alpine, also slimmed. So, okay, you will notice that all these 5 images, if I run them, they'll give me the same result. So I have no reason to use a one of 200 megabytes, for example, when something of 21 megabytes is doing the job. Okay, so I would say the winner for this again is this base image here. Let's go quickly and do the Node.js. For the Node.js, it's all configured, so we're just going to start from here. So I'll copy this base image and I will come to Node. In this folder, I'm going to open Dockerfile, and let me remove what was there before, and I paste that here. Again, we're using the traditional Ubuntu OS with the latest version. So let's build this one. Okay, let's do Docker build, and I'm gonna put Node.js 1. Okay, so let's wait for this to build. This one might take much longer because we're using the base image and we have to install all the necessary applications inside of it. Okay, very good. This one definitely took some time. So let's do Docker images. Let's go grab Node.js. Okay, this one here, the size is 993 megabyte. Okay, let's have that. Let's go back and do the other one and see what we can get. So with this one here, I'm gonna copy everything again. Vim Dockerfile, remove everything in here. And now we're using a special image with customized from the Node community, and we're using the latest version. Okay, so now let's make this one 2. Hopefully this one shouldn't take that long because we're not installing a bunch of applications. It's already customized by the Node.js community. Okay, very good. That was a lot faster. Let's go grab. All right, the size of this one, interestingly, is 1.13 gigabyte. Okay, let's see what else we can do. Let's go to Dockerfile. Remove everything there. Come to the next one. Here we're using Alpine, which should be much smaller. Anything Alpine should always be much smaller. Okay, let's make this one 3. Wow, that was quick. And look, the size of this one is 165 megabyte. From 1.13 gig to 165, and from 993 to 165. So let's see the other example, see who is the winner in this case. One more example, we're using Slim. So let's see which is the winner. So again, do Vim Dockerfile. Okay, save that. Let's build version 4. Okay, that's fast as well. Okay, version 4 is 251 megabyte. All right, so those are the 4 different images we just built. 1.13 gig, 993 megabyte, 165 megabyte, and 251 megabyte. And the winner is 165 megabyte. And so this is the winner, the one from Alpine. So you can see why Alpine is favored. In both cases, the winner of both of them are the Alpine, and sometimes you also see that the community tries to use Alpine, then see if they can even make it slimmer, remove further things that are even not needed. There's even something called Scratch. You can use a Scratch-based image. If you know how to do that very well, that could give you even much smaller images. But at the same time, remember, you need to practice a lot with this, because as you're using these specialized images, there are certain things that you may have to be aware of. Okay, very good. So in this video, I've tried to show you that the size of your images, they matter a lot. In production environment, it's not enough to just create your images. It's almost compulsory. You have to optimize them. Mostly from security perspective, from performance perspective, you want to make sure that your images are all ready for the production environment. And one of the ways you can do that is to make sure that we're using the right base image. And in other videos, I'm going to cover all these other techniques, removing caches, using Docker ignore file, reducing image layers, and using multi-stage build. All right, I hope you found that useful. Please subscribe to this channel. We're going to be doing a lot of this kind of videos to help with your cloud native education. And again, thanks for watching, and I hope to see you in the next video.